Hello everyone, in this video we are going to learn on the topic goodness of fit test, and in this we are going to study about the chi-square test with a Poisson assumption. So let us see the procedure for chi-square test with a Poisson assumption or a Poisson distribution you can call. In the step 1, compute the Poisson distribution using a formula p of x equal to e to the power minus alpha, alpha to the power x divided by x factorial, where x equal to 0, 1, 2, 3, 4 values that we are going to take. That is the integer numbers that we are going to take here. Again, in the step 2, compute the expected frequency EI. We have a formula for that. EI equals to N into P of I, where N is nothing but sum of the sample data. If the value of EI is not greater than 5, then we have to make it that value to 5. That is nothing but we have to reduce the number of intervals, that is the expected frequency we have to reduce it, and EI value must be greater than 5. If the EI value is less than 5, we are going to combine 2 to 3 values and we are going to make it the value, it must be greater than 5, so that the number of class intervals it is going to reduce here. Why? Because we are going to combine some 2 to 3 values and we are going to make the EI value that must be greater than 5. So that is about the computing the expected frequency. In the step 3, compute the chi-square test. That is, we have a formula for chi-square test. X naught square is equal to summation of I equal to 0 to n OI minus EI. That is, observed frequency minus expected frequency divided expected frequency. That is, OI minus EI whole square divided by EI. And in the step 4, obtain the chi-square test value from the table. We and x alpha comma k minus s minus 1 square. What is chi-square table? Here we have a chi-square table. Using this chi-square table, we are going to find out the alpha value, the whatever it's there in the x-axis, that is the alpha value, whatever it's there in the y-axis, that is called as k minus s minus 1. By seeing these two values, we are going to calculate the critical value, that is x alpha comma k minus s minus 1 square. This is the using chi-square test we are going to get this value. And in the step 5, we are going to compare the hypothesis, that is x naught square, whatever we calculated in the step 3, that value, if that value is less than or equal to the critical value what we calculated using a table, if that value whatever we calculated in step 3 that is lesser than the critical value, then we are going to accept the hypothesis, or else we are going to reject the hypothesis. This is the procedure for chi-square test with a Poisson distribution. So now let us see the problem based on this chi-square test on Poisson distribution. That is a problem here. Using a goodness of fit test, test whether a random number or uniformly distributed based on a Poisson assumption with a level of significance alpha equal to 0.05 and alpha cap equal to 3.64, and the sample data are given here, that is the interval they are given 0 to 11 values, and the observed frequency, that is 12, 10, 19, 17, 10, 8, 7, 5, 5, 3, 3, 1. Total the 12 values we have observed frequency and intervals 0 to 11. So now let us see the solution, how we are going to do this. Here it's given alpha value equal to 0.05 and alpha cap value equal to 3.64. So what is the difference between this alpha and alpha cap is? Alpha value that is equal to 0.05, that is we have to use this value for the critical value analysis. So whatever we are going to see the critical value using a chi-square table, there alpha we have. So there we are going to use this alpha equal to 0.05, and alpha cap value where we are going to use is using a computing a Poisson distribution. So here we have to use this alpha value is 3.64. This value we have to use alpha cap value. That is the difference between this alpha and alpha cap, and n equal to 100. So if at all if we are adding this 12 plus 10, 19, 17, 10, 8, 7, 5, 5, 3 plus 3 plus 1, you are going to get a value that is n equal to 100 values we are going to get. So that is the observed frequency total count n equal to 100. So let us see the solution here. The step 1, what we have to do in the step 1, compute the Poisson distribution. That is, we have a formula for that. P of x equal to e to the power minus alpha, alpha to the power x divided by x factorial. How many P of x we have to calculate? That is from where x value lies from 0 to 11. That is the 12 values we have to calculate. That is P0, P1, P2, P3, P4, P5, P6, P7, P8 and 9, P9, P10 and P11. All the 12 values we have to calculate. That is, we have a formula over here. Okay. Now, P of 0. P of 0 is nothing but e to the power minus alpha value they are given 3.64 into alpha to the power x. X value is 0. So if I calculate this value using a calculator, then you are going to get a value 0.026. Again, P of 1 is nothing but e to the power minus alpha. Alpha value is 3.64 into alpha to the power x. X value is 1 divided by x factorial. X factorial is nothing but 1 factorial. So you are going to get a value that is 0.095. Calculate and see that you are going to get a 0.095. Again, P of 2 e to the power minus alpha is 3.64. Again, alpha value 3.64 to the power x is 2 here, 2 factorial. Then the value you are going to get 0.13173. And the third value, that is P of 3, P of x value lies here 3, e to the power minus 3.64 into 3.64 to the power 3 x that divided by x factorial. X value here it's 3 factorial. So the next value is 0.211. Again, P of 4 e to the power minus alpha value is 3.64 into alpha to the power x, 3.64 to the power x is 4 divided by x factorial, that is 4 factorial. You are going to get a value 0.192. So next is P of 5. P of 5 is e to the power minus alpha minus 3.64 into 3.64 to the power x. X is nothing but 5 here divided by x factorial, that is 5 factorial. Value you are going to get 0.139. Again, P of 6, calculate a P of 6, that is e to the power minus alpha value is 3.64. Again, alpha to the power 6 divided by 6 factorial, are going to get a value 0.084. Again, next value P of 7, e to the power minus 3.64 into alpha to the power x. X value is 7 divided by x factorial, that is 7 factorial. The value you are going to get 0.044. Again, P of 8, e to the power minus 3.64 into alpha to the power x, 3.64 to the power 8 divided by 8 factorial. That is the value 0.020 you are going to get. Again here P of 9 is equal to e to the power minus alpha value 3.64 into alpha to the power x divided by x factorial. So you are going to get a value 8.11 into 10 to the power minus 3 into 10 to the power minus 3 minus 3. So you can able to write this as equal to, you can write this value as equal to 0.008. So instead of 8.11 into 10 to the power minus 3, convert that value and write it as 0.008. P of 10 value you are going to get, that is 2.95 into 10 to the power minus 3. So convert that value and write it as 0.003. Same like that for P of 11, you are going to get 9.77. Convert this 9.77 to 1.00 into 10 to the power minus 3, that is 0.001. You are going to get a value. So here in the step 2, we calculated the P of x value for all the values of x 0 to 11. That is from P0 to P11 that we calculated a value. Next you have to calculate the table here. So in this table, apply a g-square with a Poisson assumption, that we have a formula over here. So we have to apply that one. The formula is x0 square is equal to summation I equal to 0 observed frequency minus expected frequency whole square divided by expected frequency. That is OI minus EI whole square divided by EI. So we have to calculate for all the interval from 0 to 11 value, write xi equal to 0 to 11. And the OI values they are given, it is 12, 10, 19, 17, 10, 8, 7, 5, 5, 3, 3, 1. The values they are given. So we have to calculate the expected frequency here. So expected frequency, how we are going to calculate the expected frequency? N into Pi. Pi we calculated P0, P1, P2, P3, P4, P5 value, like that we calculated till P11 values we calculated. So EI is nothing but, here we have to see that N value is nothing but 100. So what is P of 0? That is nothing but 0.026 is Pi, P naught value. So into 100, so you will get a value 2.6 here. That is EI, it's nothing but 100 into 0.026 that we calculated in a previous step. That is 0.026. That is Pi value. P naught is nothing but 0.026 into 100, that is 2.6. Again same like that for P1. P1 value is 0.095. So into 100, we did into 100, so we are going to get a value 9.5. Again, if I calculate over here, P2 value is 0.173 into 100, so you are going to get 17.3 value. So for P3, same like that, we have to calculate. For P3, you will get 21.1. Again, P4, multiply the value of P0 to P11 into 100. N value is 100 here. So multiply, and I am writing it over here. So it is 19.2, and the next value is 13.9. Next value 8.4, and the next value is 4.4. The next value 4.4, next value is 2.0, and the next value 0.8, next value is 0.3, and the last value P11. You can able to see here 0.001, it's there. So you write that value as into 100, so you will get 0.1. So we have the condition here, EI must be greater than 5. If EI is not greater than 5, what we have to do? We have to reduce the number of intervals. So here EI value is lesser than the 5. So that we have, what we have to do? We have to add these two and make it as one interval. So here we are reducing an interval if EI value is lesser than 5. If we add these two, again if we are getting a lesser than the 5 value, then we are going to combine 3 values. Now if I add 2.6 and 9.5, I am going to get a value 12.1. So it is larger than 5. So stop here. No need to add the third value. No need of combining the third interval and making it a one interval. So I'm combining only two intervals, and if I add these two value, I'm going to get 12.1 value. So that is greater than 5. So I'm not adding the third value. So why we are going to combine here? It's in the procedure we have here the Poisson assumption procedure. In this procedure you can see here reduce the interval, that is EI must be greater than 5. If it is not greater than 5, then we have to reduce the intervals. So the next value is what? 17.3, that is greater than 5. Leave like that only. 21.5, that is greater than 5. Leave as it is. 19.2 leave as it is. 13.9 leave as it is. 8.4 also, it's greater than 5. No need of adding or no need of combining class intervals here. See 4.4, next value is 4.4. If I combine a 4.4 and 2.0, you are going to get a value 6.4. So that is enough actually. Here, why? Because it is greater than 5. So if I add these two values, that is 4.4 and 2.0, we will get a value of EI that is greater than 5 we will get. But if I add 0.8, 0.3 and 0.1, we won't get the value greater than 5. So I'm combining this 0.8, 0.3 and 0.1 to all these values. If I combine these four values, I won't get the value greater than 5. So I am combining all these 5 values so that the value we are going to get is 7.6. Adding all these 5 values, we are going to get a value 7.6. So that is greater than 5. So I am adding all the 5 values. So if I add this, now the number of intervals is reduced. How many values we got now? 1, 2, 3, 4, 5, 6 and 7 values. 7 values we got. So number of intervals now it is reduced. If I am combining these two values, means observed frequency also we have to combine. So that is 12 plus 10 is nothing but it is 22. Again here we have to combine all these 5 values. 5 plus 5 10, 10 13, 13 plus 3 16, 16 plus 1 it is 17, 17 values. So now the value of the number of intervals out of 11 intervals, now we reduce those 11 intervals to the 7 interval. Now OI minus EI, we have to compute the value, that is OI minus EI. OI is nothing but 22. 22 minus 12.1 is 9.9. Again 19 minus 17.3 is 1.7. Again 17 minus 21.1 is negative value you are going to get, that is 4.1. Again the next value, that is 10 minus 19.2, negative value here also it is minus 9.2. Again 8 minus 13.9, that is minus 5.9. Again here 7 minus 8.4, you are going to get a value negative minus 1.4. So now 17 minus 7.6, you will get a value 9.4. So this is the value, 7 interval values of OI minus EI. Now OI minus EI whole square. OI minus EI whole square, that is nothing but 98.01. 98.01. Again here OI minus EI whole square, that is 1.7 square is nothing but 2.89. Again minus 4.1 square, if I do the square, negative value will become a positive value. Again the square value 4.1 square is nothing but it is 16.81. 16.81. Again 9.2 square is nothing but 84.64. Again 5.9 square is nothing but 34.81. 34.81. 1.4 value is nothing but 1.96. Again 9.4 is nothing but 88.36. This is OI minus EI whole square. See here, if the expected value, if I add these values, that is 2.6, 9.5, 17.3, you will get a value that is 99.6 value you will get. So the expected value we should get, it is 100. We are getting 99.6. It's almost near to the value of 100, so you can leave. Or else if you want to increase, make a round figure of 13.9, you can do it as 14 value, or 8.4 you can make it as 8.5. Again 17.3 you can make it as 17.4 and make it to the 100. Or else you can leave like this itself. Why? Because 99.6 is almost the nearer value to 100. So I'm not going to do the round of values. Each value I'm not going to do any changes here. So I'm going to leave like that. I'm calculating like that itself. If you want, you can do and make it the count as 100. You can do instead of 8.4, you can take it as 8.5. There's no problem because you are going to increase only 0.1 value. So now calculate x naught square, that is chi square formula here. So OI minus EI whole square is 98.01 divided by EI is 12.1. You will get a value that is 8.1. Again, next is 2.89 divided by EI is nothing but 17.3. So you will get a value 0.167. Again, here OI minus EI whole square value is 16.81 divided by EI 21.1. So you will get a value 0.796. Next value you will get 4.4.408. Again next 34.81 divided by 13.9. So you will get a value that is 2.504. Again here 1.96 divided by 8.4, that you will get 0.23. 88.36 divided by 7.6. So you will get a value 11.62. X naught square, if I add, summation is there, summation formula, we have a summation, so add all these values, so we will get x naught square is equal to 27.82. So now let us see, we have a k equal to, we have to find out here the critical value, that is x square alpha equal to k minus s minus 1. K minus s minus 1. What is the value of k? What is the value of s here? So the value of k here it's 7, because the number of intervals we got it is 7. And the value of s is nothing but k minus s minus 1 represent a degree of freedom, and where s represents a number of parameter of estimated distribution. Here in the Poisson distribution, the s value is 1. It is a constant in a Poisson distribution. For the Poisson distribution, we are going to take a value, s value is equal to 1. And for the normal distribution, we are going to take a s value is equal to 2. So here chi square test, we are doing it for Poisson distribution. So s value, it will become 1. So now next we have to we are going to calculate the critical value, that is x alpha comma k minus s minus 1 square. Here x square alpha value, as I told you in the beginning itself, they are given the value alpha equal to 0.05. This 0.05 we are going to use to calculate a critical value. So here 0.05 alpha will become 0.05 minus 7 value number of interval, that is k is nothing but a 7 is number of intervals, minus s for the Poisson distribution, the s value is nothing but it is 1 minus 1. So 7 minus 1 minus 1, it will become 5. 0.05 comma 5. So value, let us see this value in a table. So 0.05, where we have 0.05 here, in this value here we have a 0.05, and here the 5 value it's there here. So we are going to get 11.07. The critical value we have according to the table 11.07. So using a table we calculated it is 11.07. So check whether the random number are uniformly distributed or not. So x naught square according to the table we calculated, that is 27.82 is there. So here it is 27.82. It is greater than 11.07. Therefore the random numbers are not uniformly distributed here. So if the value, the critical value, whatever the value we calculated, that must be lesser than the critical value, then we are going to accept the hypothesis, or else we are going to reject it. So here the random numbers are not uniformly distributed. Thank you everyone for watching the video. If you understood, like, comment and share with your friends. and subscribe to the channel to view the more videos on system modeling and simulation subject. Thank you everyone.